Hi, welcome to Data Literacy 101, a series of short videos about fundamental topics around data literacy, such as open data, data ethics, and working with data. You don't need any technical background for the videos to be useful. This is for you if you want to know how data and data literacy can be applied in your everyday life and in the work that you do, especially if you're a journalist working for a civil society organization, a civil servant looking to upskill yourself, or just a regular citizen interested in data. But first, a word of caution. The fields of data and data literacy are vast and nuanced, and the videos can only provide a fraction of all the available knowledge and information about a topic. However, we can still give you a general overview and a good foundation for you to start on. The videos are based on the Data Literacy 101 website, and if you want to learn more, you can visit the link on the screen or in the video description. With that said, let's start with the first topic, the big one, data. So, what is data? There's a lot of definitions out there. The Open Data Handbook defines data as unprocessed atomic statements of fact. But if you ask 10 different people to define what data is, you might get 10 different answers. This is because even if we all have an innate idea of what data is or what it should be, our different circumstances make us define data differently. So, how should we define data? Well, one way is to look at data as a structured representation of the world. It is structured because it follows logical and well defined rules as to how it is stored, how it's presented, and it is a representation of the world because it tries to capture a part of reality. It's important to note here that it's very hard, even impossible, to represent reality in its entirety. Say you go out and ask people to introduce themselves to you. You then write the information on your notebook, and it could look something like this. Jose is a 35-year-old single male living in Pampanga, while Maria, who lives in Antique, is a married female who is 29 years of age. Now, for some, data in this form is already usable, but if you want to make it easier to use, store, analyze, and even create visualizations from this data, you would usually need to restructure these sentences into something that's easier to work with, something like a table. This table gives us the same information as the sentences above, but they do so in a structured manner, making it easier to work with the information automatically and programmatically like we would in a spreadsheet application or even a database. In our table, each row represents an observation where the first row contains the names of the attributes that were observed. Each column represents one of the attributes or descriptions of the data. For example, one column here could indicate whether the person interviewed identified as being male or female. A single cell represents a data point or a specific attribute about a specific observation. In this case, 29 refers to the age of the person named Maria. And lastly, the entire table itself represents your dataset. In our example, each of the columns contain an attribute or description. It could be the name, the age, the civil status, the sex, and the location of the person being interviewed. Notice that each of the columns contain a single type of data, which leads us to the different classifications of or types of data. There are several ways by which data can be classified or typed. One of the most common classifications is between qualitative and quantitative data. Qualitative refers to data that describes the quality of something, Your name, your civil status, the color of your hair, these are all qualitative data. This data can be unstructured, such as interview transcriptions, or structured, such as in a table organizing information from an interview. Quantitative data, meanwhile, refers to data that can be quantified or measured using numbers. This can be your age, your height, your weight, or the price of a 55-inch television. Data can also be classified based on the type of information it holds. For example, numerical data uses numbers to hold information. It's a type of quantitative data. It can further be classified into discrete numerical data, which is composed of distinct values with regular gaps between them. These usually come in the form of counting numbers or integers. Examples include the number of bidders for a government project, the age of a person in years, or the number of correct answers in an exam. Continuous numerical data has, from its name, a continuous range. These usually take the form of rational numbers, and examples could be your height in centimeters, the length of your foot in centimeters or inches as opposed to your shoe size, or the amount of the winning bid for a government project. Other types of data include categorical data, which puts the object being described into a category. In the case of our example of Jose and Maria, their civil status and sex are categorical data about them. Geographic or spatial data are data that hold information connected or pertaining to a particular geographical place or your location. Jose or Maria's address could be an example of this. And lastly, time series data holds information about the value or the state of a particular thing over time. The amount of rainfall collected over time by a sensor is one example. And those are a few examples of classifications or types of data you might encounter when you start actually working with data. And that's it for the video. Stay tuned for the next episode where we talk about machine readable data. If you found this useful, give us a thumbs up, comment down below, share with friends, and subscribe. Bye!